AI and IoT drone for water purity monitoring for the organization Government of Karnataka State Pollution Control Board. So, what is the problem? What we are defining to solve the issue on this category is in the Bengaluru we have nearly 285 detected lakes. In that, many of the lakes has been contaminated with biomedical waste, plastics, and other kind of wastages which are present in the lake. So, what we are trying to do is suppose this is a lake. Suppose this is the lake of a Bengaluru, and from this part, this is the source of water. So here the wastages are coming, and here also the wastages are coming. So to locate the source of waste which is going to dump inside the lake, we are making this drone. So this is the source one, and this is the source two. So how we are gonna make this classify that from the way the wastage is going to dump inside the water. So for that we will be using a drone which will be over here on the ground control station. So this drone will hover at these places. So how we are going to locate it? So we'll be using Google Earth. We'll be using Google Earth and we'll be marking the grid lines of this. So suppose let's say this is a grid of 0, 0, 0, 1, 0, 2, 1, 1, 1, 2 and 1, 3. So the now the KSPCB, the organization of the government, wants to locate the here they wants to locate the pH, DOD, turbidity, depth of the lake. So our drone will investigate these part of the grid. So this GPS data will be going to the drone. So our drone will be over here. So the GPS coordinates will be fed into our drone. So by this, the drone will get to know this part of the grid. It should go and locate, and it should start its operation. So this operation will consist of, this drone will be consisting. So this drone. So let's say this is the drone. In this drone, the architecture will be, so we'll be using a IoT sensors box. So this IoT sensors box will be consisting of all the necessary sensors to measure the pH, turbidity, temperature, local depth of the river. So when it hovers on this particular part, the drone will launch its winch mechanism. So we'll be applying a winch mechanism over here. It will be connected to a computer on board. So there will be computer, we can call it as a microcontroller, we can take it STM32 or Raspberry Pi or Jetson Nano or any kind of a computer. And when it going to dip, so this will dip inside this location. So in this location, this will get dipped. And here it will take some part of the water samples inside the box, IoT box. And here it will be sensor 1, sensor 2 and sensor 3. So these sensors will measure the actual local depth, pH, turbidity and every kind of salinity and dissolved oxygen, and everything will be sent over to the drone. So later the processed data will be transmitted to the ground control station. So in this we'll be seeing what is the local depth and every kind of the multi-parameter test which we call will be measured over here and will be sent it to Microsoft Azure. So Microsoft Azure, we can see it over in the Wiki custom dashboard in which we can monitor all these parameters using graph and other reporting mechanisms. So then after it, so they can get to know, okay, the pH is 0 point something and we can take temperature has something. So by this, they'll complete their operation in each point of the grid and they locate to know why, and if they see that there is a difference between this grid and this grid, so they will get to know that okay, so this is the source number 1 in which the wastage is going to come. So this is the proposed solution for this problem statement. So as I said, it will be a AI and IoT-enabled monitors for water quality. So to monitor the water quality of the lake, do multi-parameter tests and maps lake using GPS results into grid point. So this is a completely open source. We can use Google Earth for making this grid mapping. And next, hovers on each point. So it will hovers at each point. It will drop the IoT sensor box using winch mechanism and measure the pH, DOD, TDS, turbidity and depth of the given grid. And next, the data has been sent to the cloud. So the data which has got from the IoT sensor will be processed on the drone and will be shared over Microsoft Azure and analyzed with shared with the stakeholders. So the policymakers and the stakeholders can see those data and take their decision to monitor this lake and can solve the issue. And periodic flights ensure real-time monitoring. So we'll be taking a periodic flight. So we'll be taking a day 1, day 2, day 3, day 4, day 5. So like this, we'll be taking something like 7 days of flight, and it will be on a periodic basis. So we can measure it effectively. Next, how it solves the problem. Manual testing, slow, costly, and inconsistent. So during manual testing, we can take boats. Boats cannot be used for this to cover this much of area within less time and less manpower. So it requires high manpower and high spaces and high time to monitor these kinds of lakes. And it is even a bit costly and inconsistent. So we had addressed this issue and we had selected drone. So you can have the question, why only drones? Why only drones? So the drones are because the drones are only. So it enables faster pollution detection. So it enables faster pollution detection and can take immediate action and response to the source which is emitting the pollution to the rivers, and can take the decision as soon as possible before it contaminates entire water. And it can use it for water management systems also. And innovation. So what is innovation and what is the uniqueness what we are implementing on these drones? So this drone has drones, a GPS, IoT sensors, and a winch mechanism. So this is the prototype which we had developed. So this drone will be consisting of IoT sensors over here, the winch mechanism, and here will be the onboard computers such as Raspberry Pi, Microsoft loaded with Microsoft Azure or Jensen Nano or any kind of microcontrollers which we can use to make this operation successful. And next, direct sampling and multiple location. So we can take direct sampling over multiple locations and can send the immediate data response to the ground control station and reduce manpower and operational costs. Absolutely, using this technology, which using this innovation, it may reduce the manpower and the cost of the lake survey and lake monitoring operations. And it is powered by real-time data sharing with authorities. So it will be on the real-time basis, not at all a delay or any kind of stuff which is going to harm the data and other necessary and multi-parameter tests. So this is a technical approach what we are doing. So this is the drone mapping, Google Earth plotting, and UAV vision planner. So your Google Earth will be taking the grid points for the survey, and those GPS data will be shared with the mission planner. Next, data collection, autonomous navigation, and in system. So it will go through autonomously to that point, it will lower the winch mechanism and it will collect the data. So sensor measurement, we can take it as pH, BOD, TDS, salinity, depth, and chlorophyll EA. So these are the parameters which will be present, which will be taking the test and will be seeing the multiple parameters and multiple will be distribution with one grid and second grid to make sure that where the source has been located and which the pollution is going to be done. And data transmission using ground control station and the cloud storage. So data which will be transmitted from the winch mechanism to the Jetson Nano, it will be transmitted to the cloud. And cloud analytics platform, whatever it is standard, so we will be analyzing it and we will be making the entire dashboard so we can make it a best outcome. And reporting and monitoring automated dashboards and trend monitoring. So we monitor trend and we make sure to give the best conclusion. And pre-survey preparation, equipment check and calibration, and flight operations and post-survey. So these three are the procedures which we have planned for mission to this drone. And this is the feasibility. So how it's feasible? It uses affordable, widely available technologies. So it uses completely available technologies which is currently in the market, such as IoT or any kind of sensors and any kind of technology which is available in the market. So we are giving, so it is used via widely available technologies and easy to implement across lakes or other water bodies. So it is easy to implement and it is powered with the latest and existing technologies, so which we can make it efficient for these kinds of operations. Modular design, scalable, adaptable. So it can be adaptable and scalable in each and every cases. strategies for overcoming stabilization and grid algorithms. So to make it stabilized, we'll be using calculated or kind of PD tuning to make it stabilized and grid readings. And regular sensor calibration maintenance. So we'll be regularly maintaining the sensor calibration so it can hover properly, and to that grid it can locate, and we can mark the grid to get the data. And encrypted secure communication. So we make sure that this data which will be going from drone to the drone control station will be secured and encrypted, so that the hackers or the other authorities cannot access those data, and it cannot measure, or it cannot take the data should not be leaked to the others. And optimize the flight paths and renewable charging. So these are the working we are working currently on optimize flight paths and renewable energy. So these are the impact and benefits. So there is a social impact, economic impact, environmental impact, and global impact. So if we talk about social impact, and so shape water and improve public health. So it satisfied the SDG of 6, 9, and other SDGs. So this innovation satisfies 3 SDGs, which is Sustainable Development Goals issued by the UN at 2015, and economic cuts down the cost of time of manual testing. So it definitely cuts down the cost, and definitely it is far more better than manual testing, and enables authority to decide what is best use. So they can by using this innovation, by using this drone, so they can make sure that which water they should classify as for drinking, which water body should they classify for industrial use, which water body they can use it for manual or any kind of household things. And environmental, the support conservation and ecosystem protection and sustainable water management. So it's sustainable water management and ecosystem protection. So it will protect the ecosystem as well as the water sustainability. And global relevance can be applied in other urban areas facing similar challenges. So it can be used in urban and rural, wherever the lake is going to degrade and other things. Provides clear classification of water quality. So it will provide a clear classification of water quality, and it can be used in any kind of environments. So this is the impact and benefit which we have made. Is the drone, is the winch mechanism, and here IoT sensors. IoT sensors, and these are the complete impact and benefits which we had discussed in this slide. So, and these are the researches and the references which we had taken. Problems observed in literature, most IoT works are fixed installations, limited depth, sampling, limited partial coverage. So there we had faced many much of gaps in the research in the previous research papers, and we had completely three research papers from IEEE, research case, IET, and many other resources. So we can make this as a complete project with innovative mindset, and can sustainable and can give clean water for the people living over those and completely dependent on rivers for irrigation and environment activities. So thank you. So for this.